Okay, you guys, we are up to section 4.5, properties of logarithmic functions. Now, what I'm going to try to do is simplify this a little bit because it's a little overwhelming. If you just look at all of these formulas at the top of page 142, it's kind of like, holy cow, there's a lot going on there. And there is, but it's simpler than it looks. Math is always that way. When you first look at some new formulas, you're kind of intimidated, but it's not that big of a deal, and I'm going to prove it to you. Try to. So first of all, you got a calculator that's going to help me communicate some ideas to you. But to start, I want to just, in this little space right here, just kind of write this. And I need you guys just to look at it. What does this say? Well, most of us, like I said in a previous lesson, most of us are so trained to read left to right, we would go log 10, 100 equals 2. But that's not how this is supposed to be read. This is supposed to be read 10 squared is 100. So I got to communicate to you that if someone asks you, what is a log? Think of it this way. A log equals an exponent. Hear that? Because what does all this mess equal? 2. What's that 2? That 2 is the exponent. So in a way, you can say a log is an exponent. Having said that, the rules of exponents are strangely connected to the rules of logarithms because what's a logarithm? It's an exponent. Okay, with that in mind, remember this? When the bases are the same and you're multiplying, you add. So strangely, if you're multiplying, what do you do to these two things? You add them to get your answer. Now watch this. I'm going to use this calculator here in a minute. This rule right here, slightly different, but you'll see the connection. How is R connected to S? Well, the way it's written, multiplication. Well, this turns into 2 logarithms, R plus log base B S. Now, what I'd like to do, I'm going to pause it and get my red marker. Un momento. All right, I'm back with my red marker and I've added some. So, what does this say? Log of 3 times 2. Now, what is that? Well, that's just 6. So I'm going to find my log button. I can do it if I have my glasses. There it is. Log of 6, and I'm just going to hit enter, and I get 0.778. So 0.778 equals. Now I'm just going to find log of 3. By the way, do you notice there's something missing down here? That means there's a 10. And my calculator knows that. 0.477 plus, what's log of 2? 0.301. What do you suppose this plus this equals? That. So I'm just kind of showing you what's going on. So just to get things started, your math might give you this as the problem and then this is the answer. Or they might give you this as a problem and they're going to say, take these 2 logs and write it as 1 log. And then you'd have to go, aha, addition means multiplication. So then you'd write it like this and you'd write log of 6. All right, with that in mind, let's try this one. The rule says,
Josh Howard, please come to the main office.
Look at this.
Josh Howard,
X to the 7th
office,
over x squared would be x to the 5th. So somehow, remember, division equals subtraction in a weird way. And that same rule is going to kind of apply over here. But this 1 log, see, I call this the log splitter or the mall. And then all of a sudden it starts making sense when I just talk like that. So you get the mall out. That's what this rule does. It splits the log into 2 logs. Same thing up here. That multiplication into addition was the mall. It split the 1 log into 2. Now here, what's the mall? Well, I just tried to prove it right here. Division somehow in a strange world of exponents turns into subtraction. So that would turn into log BR minus log BS. Okay? base b. Now let's actually put some numbers in here. Let's go log, I'll just go, oh, I don't know, let's just use 3's and 2's again. See, we already have them. All right, so there's the math problem. The instructions might say, simply write it as 2 logs. In other words, practice your log rules. So, it's like, okay, wait a minute. According to the rules, division equals subtraction, but I gotta take the top one, log of 3, and I gotta subtract the bottom one, log of 2. Well, this is just 1.5, so I'm gonna take the log of 1.5 and hit enter. I get 0.176 equals log of 3, we already know it, it's 0.477. Log of 2, we already know it, 0.301. What do you suppose this minus that is? This is very accurate, okay? So you can trust these rules, but I need to communicate something to you. Your math homework is going to have problems that say something like, take these 2 logs and write them as one single log. In other words, you have to go, okay, wait a minute, subtraction, what does that mean? Division, and that would be your answer. There's going to be other problems that say take the single log and write it as 2 separate logs. Well, it just depends on what the instructions are. This one is just, there's really no connection. So this is kind of connected to this is kind of connected to this in a way. This rule is just kind of on an island by itself. It just works, okay? So what is this even saying? It's saying, if I was to go like this, let me give you an easy one. 2 cubed. Yeah. It's saying that, and again, what is the b? It's an indivisible 10, so I hope that's not throwing you. But it's saying you can take that power and you can put it in the front. So there's my power, and I'm going to put it in the front. And now with my red marker, I'm going to actually check into this. So what is 2 cubed? It's 8. So I'm going to go log of 8 is 0.903 equals, and now I'm going to, like PEMDAS, I'm going to do this first. Log of 2, enter. That's 0.301, but then I'm going to multiply it, so that's 0.301 times 3. What do you think that is? 0.903, okay? Now, this is absolutely fascinating math if you're a math nerd like I am. It does have real-world applications, which makes it even more interesting. But the thing I'm going to ask you right now, see how much time I have? Yeah, all right. So look at it. Do you see this right here? I'm curious. I told you I typed in log, and I said I figured out 2 cubed is 8. And then our calculators spit out that equals 0.903. Throwing this in for free, but it's important you kind of keep track of this while we move forward. Isn't there an invisible 10 right down here? So what does this say? Don't you dare say log 10, 8 equals, no. You say 10 to the 0.903 power equals 8. How bizarre is that? Well, what's 10 to the first power? 10. So does it make sense that 10 to the 0.903 would be equal to 8? Yep. And that's what we're doing, but then we're applying some crazy rules to it. By the way, before I hit end, some of your math might have this, and what you're going to do is you're going to put a 3 here. You're going to go this way. You're going to write it like that. Or sometimes you're going to take this exponent and you're going to write it in the front as a coefficient. It just depends on how the problem's given to you. But this gets people confused because you're going to hear me say, look to apply law, this is called a law. Look to apply law 3 first. And you're going to be thinking, well, I don't get it. You will once we do a few of these sample problems in your packet.